All right, so let's do a heat of combustion problem. When 2 grams of propane, C3H8, is combusted, the temperature of 500 grams of water in a bomb calorimeter rises by 48.3 degrees Celsius. What is the heat of combustion of propane in kilojoules per mole? So for this particular problem, we need to recognize if we can figure out how much heat the water absorbed, then we can set that equal to the amount of energy released by the propane. So we have enough information to figure out the heat absorbed by the water. So you will use Q equals MC delta T to figure out the amount of heat gained by the water. You're given the mass of the water, 500 grams. You know the specific heat of water is 4.18 joules per gram per degree C. And you know the temperature increase is 48.3 degrees C. So when you do that math, the amount of energy absorbed by the water is 100,947 joules, which we can write in terms of kilojoules. And I'm going to go to 3 sig figs because there's 3 sig figs in the problem, in the mass and in the temperature change. So now if this is the amount of heat absorbed by the water, then that must be equal to the amount of heat released from the burning of the propane. So that equals the amount of heat released from the propane. However, it's negative. So we know that there's negative 101 kilojoules released when 2 grams of propane is burned. But we want to figure out how many kilojoules of heat are released per mole of propane. So we know that propane is C3H8, and if you take 3 times the molar mass of carbon plus 8 times the molar mass of hydrogen, you get 44.10 grams per mole. So if I write 44.10 grams over 1 mole, my grams cancel, and I'm left with 2,227 kilojoules per mole. However, since I'm given 3 sig figs, I can probably write that as 2,230 kilojoules per mole. So the answer to this problem, and we should make that negative because it's heat that's being released, is negative 2,230 kilojoules per mole. That is the heat of combustion for propane.